Our first application to calculate the area below a curve using definite integrals is going to be consumer surplus. So I've just jumped ahead to the next slide so that we can physically see the area before we do the calculation. Now, consumer surplus, is the area below the demand curve, but above the price. And here we've got our vertical intercept where the demand curve cuts the vertical or price axis. It is 30. We can see that the price is 10 and that the quantity is 5. All this information is from the previous slide, the calculation which we're going to do just now. So therefore, to calculate this area, half base times height, I'm going to have a half times. This distance is 30 minus 10, it's 20. So a half times 20 is 10 times 5, it's going to give me 50. So this area is 50. And this is easy because this is a linear function. Now, when using definite integrals, it's useful for a nonlinear function, which we'll see shortly. But with definite integrals, what it calculates is the area below the curve between two limits. Now, the limits in this example is going to be 0 for the lower limit and 5 for the upper limit. So it calculates this entire area. However, for consumer surplus, we only want this portion. So we need to take the entire area and then subtract this bottom area so that what you're left with is consumer surplus. So now let's go back to the calculation. So it says find the consumer surplus at Q equal to 5. For the demand function, P is equal to 30 minus 4Q. So if Q is 0, we can see that the price is equal to 30, and that is the vertical intercept. We can see that the quantity is 5, and where the quantity is 5, we'll see that the price was equal to 10. And that was the information that was plotted on the curve. Now, to use definite integrals to solve for the consumer surplus, I need to integrate this function, this demand function f of q. So I'm going to place it in brackets between my integral sign between the lower and upper limit and between dq. So I first need to integrate this. So therefore, this is simply going to be 30q, and it's going to be minus 2q squared. Remember, q is raised to the power of 1. So therefore, I'm going to say n plus 1. 1 plus 1 is 2. And therefore, I'm going to take the coefficient 4 multiplied by 1 over n plus 1. And that's 1 over 2 times 4. That becomes 4 over 2, which is simply minus 2. So therefore, I have 30q. Remember, this is, you're just integrating a constant. So therefore, it's simply 30q minus 2q squared. Now we place it in our square brackets and we have our lower limit and our upper limit. And I know that I need to evaluate it at these limits. So you first evaluate at the upper limit, which is 5. And then you would evaluate it at the lower limit, which would be 0. But if you were to substitute 0 into the indefinite integral, what you get would just be 0, as you saw in one of the earlier examples. So therefore, this is simply going to be 30 times 5, which is 150, minus 2 times 5 squared. 5 squared is 25, times 2 is 50. So 150 minus 50 is 100. But remember, I said that what we have just gotten is that entire area between the limit of 0 and 5 below the demand curve. However, there is that square that wasn't shaded purple that we don't want because the surplus is above the price of 10. So therefore, to get the consumer surplus, you have to say 100, which is the entire area below the demand curve between the lower limit and the upper limit, 0 and 5, minus the product of PQ, because that area is the area of a square, the price times the quantity. The price was 10 and the quantity was 5. 10 times 5 gives you 50, so 100 minus 50 is simply 50, and that gives you the consumer surplus. So if you have a look, we took the 100, which is this entire area, and we said minus the product of PQ, which is this area. So by subtracting this, what I was left with was my consumer surplus. Now, of course, if it's a linear function, solving by using half base times height or breaking it up into smaller areas, it's quite simple. But if you have a non-linear function, then for obtaining your area below a curve using just half base times height, if it were a triangle or a square, etc., you're not going to be yielding an accurate answer. So now you are going to use definite integrals for all of your applications in 235. For the exam, you need to use definite integrals. So it says find the consumer surplus at Q equal to 8 for the demand function P is equal to 100 minus Q squared. So therefore, you need to find the definite integral of this demand function with respect to Q. So in brackets, you're first going to integrate your demand function, then evaluate at your lower limit and your upper limit. So therefore, this is just a constant, so this is just going to be 100Q. And if I integrate this, n is 2, so therefore n plus 1, 2 plus 1 is 3, so I'm going to get Q cubed. My coefficient here is 1, but remember you have to take that coefficient and then times it by 1 over n plus 1. N plus 1 is 2 plus 1, so it's 1 over 3 times 1. It's simply 1 over 3. And don't forget, it is negative 1 over 3. Q cubed. And now we're going to evaluate at our lower and upper limit. So we say f of the upper limit minus f of the lower limit. So we first evaluate at the upper limit, which was 8. And of course, if you evaluate at the lower limit at 0, it would simply be minus 0. So therefore, this is your answer, 629 and a third. However, this gives you the entire area below that demand curve between the limits of 0 and 8. But we only want the consumer surplus, which is the area above the price. So therefore, I need to determine what the price would be when the quantity is equal to 8. And if you substitute 8 in over there, you're going to get 8 squared, and 100 minus 8 squared is 36. So P is 36. So therefore, if I take this area and I say minus the product of price times quantity, it gives you that sort of square shape at the bottom, and 36 times 8. If I subtract that from this entire area, what I'm left with is my consumer surplus. And that is what you have. This is your consumer surplus for that particular function. Now, the initial value that you got was this entire area below the demand curve up to the quantity of 8. But we only want this portion, so therefore we needed to subtract this area. So I hope you understand how we go about solving for consumer surplus. We will now move on to producer surplus. So again, I'm going to skip ahead to the diagram. And again, this is a linear application before we look at a non-linear application. Now with producer surplus, you know that it is the area above the supply curve, but below the price line. Right, so this is your producer surplus. We'll have a look at the function in a moment, but you can see that the price is 30 and the vertical intercept, I'm not quite sure what this value is, but we'll see that in a moment. And you can see that the quantity is 9. Now, with definite integrals, can you guess what area will be calculated? It is the area below a curve above the x-axis, in this case quantity, this axis, between the limits of 0 and 9. But this isn't the area that we want, right? We want this area. However, can you determine this entire area? It is a rectangle, right? So therefore, I could say the product of my price, which is 30, times my quantity, which is 9, I'd get this area, this rectangle. And surely if I subtract this area that I would have gotten using definite integrals, what I'd be left with is my producer surplus, this purple shaded area. So let's have a look. So to find the producer surplus at a quantity equal to 9 for the supply function, P is equal to 12 plus 2Q. So you can see that vertical intercept was 12. Then you want to use your definite integral of the supply function with respect to Q between the limits of Q equal to 0 and Q equal to 9. So there's your lower limit and there's your upper limit, 9. So therefore, we integrate this function first, and you're going to get 12q plus q squared. How did I get the q squared? Well, q is raised to the power of 1, so 1 plus 1 is 2, and therefore 2 times 1 over n plus 1. So 2 times 1 over 2 becomes 2 over 2, which is simply 1. So therefore, if I evaluate now what I've integrated between the lower and upper limit, I first check at the upper limit, f of b, and in this case, the upper limit b is 9, minus the lower limit, which is 0. It would just be 0. So therefore, I've got 12 times 9 plus 9 squared. You're going to get 189. But as I said, that was this entire area below the curve. However, we want this. So therefore, if I get the product of this rectangle, P times Q, and I subtract the area that I got using definite integrals, what I get is my producer surplus. So that's exactly what is done here. If you say P times Q, P was 30, Q was 9, minus 189, which was the area beneath the supply function, what you're left with is your producer surplus, and that is 81. Now, of course, in this example, you could have just worked out the area of a triangle because that is what it is in this particular example. But as you will see in economics, in microeconomics, and in your third year, your consumer, your producer surplus, it does not have to be this shape, especially when you start looking at areas and you include things such as tariffs and quotas, and you have to factor in changes to your surplus and welfare and a deadweight loss. It's not as straightforward as looking at the area of a triangle. So therefore, we need other tools, and here we will use definite integrals. So here's an example where you have a nonlinear function, and your q is equal to 4, and here is your supply function. So first integrate this function, your supply function 3 plus q squared, between the limits of x equal to 0 and x equal to 4, or q equal to 0 and q equal to 4. So I first integrate that. This is simply going to be 3q, and this is going to be 2 plus 1 is 3. So therefore, I have 1 over 3 times 1, and that's simply 1 over 3. So I've got a third q cubed, and I evaluate it at my lower and upper limit. And therefore, if I evaluate at my upper limit first, I substitute the 4 in wherever I see a q, and I determine that it is 33 and a third. Of course, you evaluate at the lower limit, it's simply minus 0. So therefore, the area beneath the supply function between the limits of 0 and 4 is simply 33 and a third. However, my producer surplus is above the supply function, but below the price. And the price, you can see, if you substitute 4 into this function, 4 squared is 16 plus 3 is 19, and quantity is 4. So price times quantity, 19 times 4 minus 33 and a third, which is the area beneath the supply function. What it leaves you with is your producer surplus of 42 and 2/3. So using integral calculus or definite integrals, what you would have obtained is this area beneath the supply function, but between these limits. However, you want the producer surplus. So therefore, I work out this entire shape and I subtract this region from that, and what I'm left with is my producer surplus. There are a couple more exercises. I'll go through one more in the next slides.